Hello Hackaday, I'm going to show you how to build a single transistor latch. I have here the 2N4401 transistor. It's an NPN. Pin 3 is the collector. Usually the collector is wired to positive and the emitter is wired to negative. I'm going to flip this upside down. Pin 1, I'm going to put at the top of the circuit. Then I'm going to connect pin 1, which is the emitter, directly to power. Then I'm going to take an LED off the collector. Take a resistor. And this is the negative side of the circuit, even though it's the collector. Power it up to minus. Sorry, I don't have another green wire at the moment. And it turns on. So what's happening here is that you have something called breakdown voltage. Transistors will usually turn on and off only when the base commands them to, except if the voltage between the emitter and collector is greater than a certain value, they'll turn on anyway. When a transistor is wired in reverse, the breakdown voltage is much lower than usual. Usually is around 6 volts. So you see around 8.5, it starts to turn on. The LED takes a couple volts, the resistor takes a little. There's about 6 volts across the transistor when that happens. That's pretty typical for most small transistors like this. So one thing that you can do is you can control this somewhat with the base. So I can put a resistor on the base. And if I put the base to positive, it turns on more. If I put it to negative, it turns off. But that's not a latch. We want a latch. I figured out that if I take a 10K resistor between the base and the collector, and if the voltage is just right, currently with this one it's between 9.6 and 9.8 volts. What you get is a latch. Let me get rid of this voltmeter. You put it to power, it starts conducting, it stays conducting. You put it to ground, it shuts off, and stays off. Now why does this work? I'm not sure. When it's on, it's not much different than if that resistor wasn't there. If you pull out the resistor, it'll stay on, because without the resistor it was on anyway. When I turn this off, for some reason the resistor is important, because if I pull this out, it stays on. I can't get it to stay off. Only when I put the resistor between the base and the collector. Does this behave like a latch. Why is that the case? Notice there's no capacitors in here, there's no oscillators in here. There's nothing to hold the state other than the transistor itself. This is just a power supply. So why does this work? Please try to duplicate this, try to speculate. I'm going to do a little bit of analysis on my own to try to figure it out. This worked with the 2N4401. I tried a second one just in case somehow my transistor was damaged and got converted into something silly like a UJT or something by random chance. But the only thing I had to do was adjust this voltage slightly to make it work. Ooh, I just turned it on. It is a little sensitive to noise, because if you put any input into that base, it might turn on. If it's floating, it's fine. Yeah, I tried a 2222. It didn't work. I can't find my 3904s. I have no idea where they went. But I tried two different 4401s, and they both worked. I don't know what is special about a 4401 besides the 2222. Those three transistors are all very similar, but for some reason, 4401s work as latches when they're backwards. Please try to duplicate it, try to prove it, try to disprove it, try to come up with a better one. Try to figure out why it works. Why shouldn't it work? But yeah, it's interesting at least. And that's one transistor latching one bit. No other passives other than some resistors. There's no diodes, there's no RF, there's no like strange, there's no light dependent resistors, phototransistors, none of those like usual cheats that you try to use. It's just a transistor latching itself on and off. Thanks for watching.